If we have dichotomous outcomes and a single explanatory variable, the simplest way of analyzing this is constructing a 2x2 table and conducting either a chi-squared test or comparing proportions using relative risk or something along those lines. In this video, we're going to cover the chi-squared test, which is there to tell us if we have a difference. It's not going to tell us the magnitude of difference, but it will tell us if two proportions are different. And to help us out, we're going to use our indomethacin simplified data set from this week. You can see here that we have a grouping variable. In group, 0 means they received the placebo, and 1 means they received the NSAID indomethacin. That's our intervention group. And the outcome is, again, dichotomous. So they either do develop pancreatitis, that's the 1, that's a bad outcome, or they don't, 0. That's a good outcome. So let's get this into SPSS and see if we can carry out a chi-squared test. So I copied the data. I'll just simply paste it in. And hopefully this is a whole bunch of 1s and 0s. This should be totally fine. To make my life a little bit easier, what I'm going to do is go into the variable view and say what those 0s and 1s mean. And there we just simply use the value labels. So we can define what those values are. So if it's a value of, in group, 0, let's call that placebo. And if it's a value of 1, let's call that indomethacin. We'll say OK. And this is going to help us with our output later. Instead of telling us 1 and 0, and we have to remember what that means, now it's going to tell us placebo, indomethacin. For the outcome, we again have 1 and 0, but in this case, 0 doesn't mean placebo. It means no pancreatitis. I'll just keep it simple and write no panc. And for 1, I'll put panc. So I know my good outcome, I know my bad outcome. I say OK, and you can see here now the values have something in it. And depending on how your SPSS is set up, it may very well change how this looks. Okay, great. If it doesn't change, it doesn't matter. It'll still work, I promise. So now what we need to do is use the Crosstabs function to generate a nice 2x2 table. So we'll go to Analyze, Descriptive Statistics, and in this case, Crosstabs. So this will tabulate or count up the events across two different variables. Now, by convention, we put our group in the rows, and we put our outcomes in the columns. This will generate a 2x2 table. What we want to do is add some additional statistics here. So we'll click Statistics. We do want it to carry out a chi-squared test for us. And we would like risk in this case. If we were doing some kind of a reliability study, we would use kappa. If it were some repeated measures, we'd use this McNamara. It's not. We just want risk in this case. We're comparing the risk of pancreatitis across these two groups. At this point, we're good here. We'll say OK. And then we're greeted here with this output window. OK, what the top is telling us is that we don't have any missing values. That's good. We get our cross tabulation. So this is your 2x2 table. It's set up a little differently than I would like it set up, but that's okay. We can still use this. We get the same statistics. So this is fine. What we're looking at now down here would be all the different chi-squared tests. So here's where we're actually comparing the proportions. And there's a lot of different outcomes here. If we had a really small sample, like if any of these squares here, the placebo group that didn't have pancreatitis, or those that did, or in the intervention group, how many of those didn't or did have pancreatitis. If any of these 4 cells right here had 5 or fewer counts in them, Then we'd want to do one of these continuity corrections or the Fisher's exact test. But as you can see, it doesn't matter what we use. All of these tests are significant. Doesn't matter. So just the standard Pearson chi-squared, this is totally fine. We'll run with this one, but they all agree this is what we would report. We'd say we had a chi-squared statistic of 7, well, we'd round it to 8.00 with 1 degree of freedom and p equals 0.005. So in this case, we reject the null. In other words, the proportion of folks who develop pancreatitis differed between these two groups. And just looking at our 2x2 table here, we can see we've got higher rates in my placebo group of pancreatitis. So indomethacin seemed to help. How much did it help? Well, we can come down here, and now we've got our risk estimate. So there's a couple of things that we're putting out here. We've got our odds ratio, and I provide some notes on this. This compares the odds, not the proportion. So this would be the odds in the placebo group compared to the indomethacin group of, in this case, not developing pancreatitis. So you can see here they had about half the odds. That doesn't mean that they were half as likely. It just means they had half the odds. Okay, different thing there. But we want to talk about likelihood. We want the relative risk. And that's what comes down here in these two. Here we're looking at for the outcome of no pancreatitis, what are we seeing in the placebo relative to indomethacin group? And so this is telling us that the placebo group was only about, let's say, 91% likely to not have pancreatitis compared to the indomethacin group. So there was about a 9% reduction in not having pancreatitis. That's a bad thing. So we don't want the placebo, we want the indomethacin. Of course, we want to look at our confidence intervals. Nowadays, instead of looking for 0, we're looking for 1 in these confidence intervals. And that's because, notice what they're doing here. They're showing you right here, it's division. And again, I have notes on this. Check them out. We don't see 1. This is statistically significant. Of course it is. We have the chi-squared telling us that. Finally, the readout that we do care about, what's the risk of pancreatitis that is the bad outcome, in my placebo group? Hey, they're about 85% more likely. And why is that? Because this is greater than 1. If it was 1, they'd have equal risk of pancreatitis. But I'm seeing a value greater than 1. 1 is not in my confidence interval. So there's a significant increase in the risk of pancreatitis in the placebo group compared to the indomethacin group. So this is actually what we'd want to report. This is probably the most important outcome here. What's the risk of pancreatitis? And so we'd say it's about 1.85. That'd be my relative risk in the placebo group, with a confidence interval ranging from about 1.2 to about 2.9. Truth be told, I actually care about the risk of pancreatitis in the indomethacin group. I could divide all this 1 by my 1.85, right? Just get the reciprocal. But there's an easier way of doing this. And I will show you that in another video whenever we cover the simple 2x2 calculator that I've developed for you. At this point, we're pretty well done with this. If you have any questions on how to conduct the chi-squared test, make sure you drop those in the questions box.